Okay, this is page 26 and 27 in your notebook, and it's going to be titled Function Notation. Function Notation. Alright, so we're going to write some things down on page 27, and then for 26 we're going to look at a few graphs that I'm going to give you a copy of. Alright, so to start off, let's take a look at what function notation looks like. So for example, we could say f of x equals 3x plus 4. And this right here defines the name of the function. So the name of the function is f of x. Oops. And then we read this f of x. So it's, you want to make a note here, it's read f of x. And then this letter right here is your input. So your input is x. So that's what you would put into the function, plug into the function. So that's your input. This part right here generates your output. And function notation is nice to use when you're going to evaluate a function for different values of x. That way you don't have to write this function every time substituting in a new number. So it has some shortcuts with it. So that's why function notation is nice. So for example, let's try a couple examples. So number one, if I just wrote f of -1, so that would be what the question says. You would have to know that the function is f of x equals 3x plus 4. So what you're going to do is take -1, notice -1 went in for the input, so you're going to put -1 in for all the x's over here. So it's going to be f of -1 equals 3 times -1 plus 4. And then you just evaluate it. So 3 times -1 is -3. And -3 plus 4 is +1. So that, therefore, f of -1 equals 1. That would be your answer. Okay, let's try another one. So number 2, I'm going to evaluate f of 8 and then plus 3. Okay, so if you have one like this, you're going to start with f of 8. So start here, evaluate f of 8. So that means I'm putting 8 in for the input, and the input up here is defined as x, so it's going to be 3 times 8 plus 4. So this part is going to be 3 times 8 plus 4. And then once I get this answer, I'm going to remember that there's a plus 3 here as well. Alright, 3 times 8 is 24, so 24 plus 4 gives us 28. And then bring down the plus 3. 28 plus 3 gives us 31. So therefore our answer to this entire problem is 31. Alright, now let's try a different function. So let's pretend, I'm running out of space here. I'm going to put a line and I'll just keep going here. So let's give our new function name g of x. I'm going to define a new function that's called g of x, and g of x is equal to the absolute value of 3 minus 4x. Alright, so there's our g of x function defined. So number 3, let's evaluate g of -2. So I'm putting -2 in for all my x's. So that would be equal to the absolute value of 3 minus 4 times -2. Close your bar. So notice I just put it in for the x. In for the inputs went -2. Alright, so now I evaluate this. Absolute value bar means get a number on the inside before you take the absolute value. So -4 times -2 is +8. So 3 plus 8 is 11. So I got absolute value of absolute value of +11. How far is +11 from 0? 11 spaces, so the answer is 11. Okay, so next to that I have room for number 4. Let's try g of 4 minus g of negative 3. G of 4 minus g of negative 3. And I'm going to add on to my paper here. All right, so g of 4, we're going to evaluate this one first. So that means it's the absolute value, putting a 4 in for all the x's in here. 3 minus 4 times 4. Then minus g of negative 3. G of negative 3 would be the absolute value of 3 minus 4 times negative 3. All right, so each one individually here. Negative 4 times 4 is negative 16, so its absolute value of 3 minus 16. And 3 minus 16 is absolute value of negative 13. An absolute value of negative 13. How far is negative 13 from 0? 13. All right, over to this side. Using our order of operations, what's negative 4 times negative 3? That'd be positive 12, so 3 plus 12. 3 plus 12 is 15. Absolute value of 15 is 15. All right, what do I do with my two numbers that I have? So g of 4 is 13, g of negative 3 is 15. I have to bring down the minus sign in the middle. 13 minus 15 is negative 2. So that would be your final answer for that one. All right, one more on this side. Hopefully you have more space than I do. Let's try h of x this time. And let's say h of x equals 2x minus x squared. 2x minus x squared. All right, this would be number 5. So number 5 says 3 minus h of 4. 3 minus h of 4. All right, so 3 minus, I'm putting a 4 in as my input now, so 4 is going in for my x's. So it's going to say minus. Now, it's minus this whole function h of 4. So if you want to think about this as all one big thing. H of 4 means 2 times 4 minus